Hello and welcome back. Systems administrators that work in your organization have the usual task of having to remotely administer cloud-hosted virtual machines, on-premise servers, and even edge devices. They often need to remotely connect to those virtual machines in order to perform day-to-day administrative tasks. The problem with standard approaches to connecting to those servers includes things like having to open inbound ports, maintain bastion hosts, or manage SSH keys. In this video, I want to talk to you about the AWS Systems Manager's Session Manager service that provides a highly secure method of connecting to those cloud-hosted virtual machines, remotely administer those servers without having to open those inbound ports, maintain those bastion hosts, or manage a wide range of SSH keys. Let's take a look at AWS Systems Manager's Session Manager. And so here's George, our AWS Systems Administrator. If George now needs to access backend Linux and Windows-based EC2 instances that are in the private subnet of a VPC, we need a mechanism for him to connect to those servers. And traditionally, we would deploy some bastion hosts in the public subnet, open inbound ports that are necessary to connect to those EC2 instances. So in the case of Linux instance, we'll be opening port 22 inbound to allow SSH traffic. In the case of Windows-based instances, we may open port 3389 for the remote desktop protocol to get the GUI interface access to those Windows instances. Regardless of whatever you do and however you set this up, the traditional approach involves opening inbound ports and exposing your network to potential attacks from the outside world. What we want to do is get rid of all of that, and we want to access our backend EC2 instances without having to use those jump boxes, those bastion hosts, and without having to open those inbound ports. And so to help George access those servers in the private subnet of your VPC, or even the public subnet for that matter, you can make use of a service called the AWS Systems Manager Session Manager. Now, AWS Systems Manager Session Manager is one such tool that will allow you to remotely administer your EC2 instances without having to open those inbound ports, without having to use jump boxes. In terms of the architecture, it requires you to deploy Systems Manager agents on your EC2 instances. Now, there are several AMIs on the AWS platform that come with the agent pre-installed, but if you're using another type of AMI that doesn't have it pre-installed, you can always provision your EC2 instances using the user data script, so a little script file that allows the agent to be installed at launch time. And obviously, as a corporate organization, you may wish to include the System Manager agent in your corporate AMIs. In addition to that, you would also need to set up an IAM role. Now, an IAM role plays an important part in allowing different services on AWS to talk to each other, and Systems Manager Session Manager is no exception. It needs an IAM role in order to communicate with your EC2 instances, and for your EC2 instances to give that communication back, those updates back to Systems Manager Session Manager. One of the really crucial and important features of AWS Systems Manager is the ability to actually log all of your interactions that you are performing on your EC2 instances. In fact, AWS Systems Manager offers you two options. You can choose to send log traffic and stream actual interactions with your EC2 instances to AWS Amazon CloudWatch logs, and or send the same type of information to an S3 bucket that you configure to store logging information. So you've got two destinations there for all of your log information. This allows you to audit all of your interactions that you perform on your EC2 instances at a very granular level, and I'll demonstrate this in the hands-on exercises shortly. Now, when you're setting up your logging infrastructure, so your CloudWatch and your S3 bucket, there's a few things that you need to take into account before you can actually have that communication or the streaming data go into CloudWatch and your S3 bucket. For one thing, you need to ensure that you update your IAM roles so that communication and interaction between your EC2 environment and your S3 buckets can actually take place. You can also set up KMS, Key Management Service, in order to set up and define your own customer managed keys for encryption and decryption services, and I'll showcase how we do this in the lab as well. Furthermore, you'll also need to update the IAM roles so that you can also allow communication between your EC2 instances and CloudWatch to take place. And in addition to that, you'll also need to ensure that Amazon CloudWatch is permitted to interact with KMS, and for that you'll be updating the KMS key policy, and again that too will be demonstrated in the lab. So once this is all in place and you have the infrastructure ready to go with all the IAM roles and all of that setting configured, then your systems administrator, George in this case, can use Session Session Manager to remotely administer and access your EC2 instances in the backend in the private subnets of your VPC, or even in the public subnets, without having to use bastion hosts or open inbound ports. In fact, you can actually use Session Manager and configure it to remotely manage your instances using SSH without opening inbound ports, as well as tunnel Remote Desktop Protocol using port forwarding feature of Session Manager to get remote access to your Windows-based instances and the Windows Desktop GUI interface. So that's all enough about the architecture and the theoretical concepts about how this should all work. Why don't we jump onto the AWS Management Console and set this all up? Let's do that next. Okay, so here we are on our AWS Management Console. I'm currently in the North Virginia region, and that's where I'm going to operate this particular lab exercise from. Now, the first thing that you will need to do in order to try out the labs in this how-to guide is to ensure that you have a VPC in place. Your VPC needs to be a multi-tier configuration, so it needs to have public and private subnets. What I would strongly recommend is that you actually build your VPC for some of our future labs in one shot. So this particular VPC, for instance, the PAPS Dev VPC, is one that is comprised of 6 subnets. Okay, so I've actually got 6 subnets for you, 2 that are public subnets, so they effectively allow us to deploy things like load balancers in the public subnet, 2 app subnets, which are private subnets that are going to be used to deploy our EC2 instances, and 2 database subnets. But ultimately, what I would like to do is ensure that you have 2 private subnets and that you've deployed EC2 instances there. You want to make sure that for the purposes of this lab that you have an internet gateway attached to your VPC, as well as a NAT gateway, okay, in order to allow the EC2 instances to communicate with the outside world, but also for it to communicate with the likes of S3 and with CloudWatch. Okay, so you will need a NAT gateway in place. So currently have a NAT gateway in place, and that NAT gateway is sitting in fact in the public subnet 1, okay, and is used to allow instances in the private subnet to connect out onto the internet and to access those public services on AWS, such as Amazon S3 and CloudWatch. Okay, so accordingly, you will also need to ensure that you have the necessary route tables. I've got a main route table. Okay, and the main route table is associated with the app subnets. You can see app sub 1 and app sub 2. Okay, and it has a route to the internet via the NAT gateway. I've got a public route table. The public route table is associated with the 2 public subnets, public subnet 1 and public subnet 2, and it has a route to the internet via the internet gateway. And so ultimately, as per our diagram, we're going to be deploying some EC2 instances in the private subnet, and then we want to use Systems Manager, Session Manager to connect into them. Finally, if you'd like to know how to actually build out this VPC, if you haven't done it before already, then you can click on the how-to guide shown in our GitHub repository, the link of which is accessible through our resources section or in the description below. Okay, so the next thing that we need to do in order to get all of this to work is to configure that IAM role. Now, an IAM role is going to allow the communication between your Session Manager and the EC2 instances. So we need to jump back into the AWS Management Console, get into IAM and configure that role. And so if I do a quick search for IAM and take you to the IAM dashboard, so we go there first. And in IAM, you want to go to IAM roles. You want to click create a new role. And you're going to be creating an AWS service role, and you're going to be trusting EC2 instances. Okay, so EC2 instances are going to be able to communicate with your system management service. We'll click next. And the policy that you're going to apply to this role already exists. So AWS provides a managed policy. And if you quickly do SSM and filter on that, the policy that you want to attach to this role is the Amazon SSM Manage Instance Core. This policy has the necessary permissions to allow communication with Systems Manager from your EC2 instances. So we're going to click next on that one. That's the policy over there. You can see that the trusted entity there is the EC2 service. We're going to give it a name. Okay, I'm going to call it SSM EC2 Instance Profile, and I'm going to create that role. So that's the role that we're going to be using when we launch our EC2 instances. Okay, so we now have the role in place as our base role. We've got our VPC in place. The next thing that we can do is actually go ahead and launch a couple of EC2 instances. So let's do that next. So I'm going to open the EC2 console in a different tab. And we'll go ahead and launch a couple of EC2 instances. And I'm going to launch one Linux-based instance and one Windows instance to demonstrate the two types of instances you can work with. Obviously, you can work with Mac OS now as well. We call this one Linux 01. And we're going to use the default settings. You just need to make sure that you put it in the right network. Now, for the key pair, I'm going to say proceed without a key pair. And for the network, I'm going to click Edit, select my PAPS Dev VPC, and then go down and also ensure that the auto assign IP address is disabled, because remember, we're placing this EC2 instance in the private subnet. It doesn't need a public IP address. Select an existing security group. So I'm going to select the PAPS Dev App SG security group. Now this security group only allows inbound traffic on port 80. It doesn't allow inbound traffic on SSH or 3389. So in fact, let me just quickly prove that to you by going back to my VPC console. I've created some security groups as a precursor to this exercise. The PAPS Dev App SG is going to be used to associate my EC2 instances with, and it allows only port 80 inbound, and that too only from the load balancers security group. So if you look at the source of that traffic, you will see the source of that traffic is PAPS Dev ALB SG, ALB standing for Application Load Balancer. So this application load balancer security group is going to be associated with an application load balancer that we do in one of our other labs in this series. Okay, so that's the only rule that we're allowing inbound, and I just wanted to quickly show you that. Back to my EC2 console where I'm launching my EC2 instance. I'm going to leave all the other configuration as it is. I am going to make sure, however, that my server is being launched in the app subnet. So let's put this one in app sub 1. Okay, this is the Linux server that we're deploying in PAPS Dev App Sub 01, so the application subnet, a private subnet 01, which is in availability zone US East 1A. Okay, so as we scroll down, I'm going to click on the advanced details, and the next thing that we want to do, and this is really the crucial element here, is to select the correct IAM role or the instance profile that will allow my EC2 instances to be trusted by SSM. So we created that IAM role a few moments ago. I'm going to select the same IAM role, which is the SSM EC2 instance profile role. And we're going to leave everything else as it is, and we're going to go ahead and launch that instance. So we're launching a Linux-based instance now. Next, very quickly, I also want to launch a Windows-based instance. So whilst that is happening, I'll click Launch Instance. This is going to be my Win SRV01. I'm going to go with a Windows AMI. And specifically, I'm just going to select the base 16, the 2016 base AMI. Again, I'm not going to select any keys or create any keys. I'm going to make sure I put it in the right network though. So that's my PAPS Dev VPC in my PAPS Dev App Sub, so application subnet. So I'm going to this time select the App Sub 2. So this one is in US East 1B, in the US East 1B availability zone. But this is the other subnet, the other application private subnet. Okay. And again, the same pattern, no need for public IP addresses because this is in the private subnet. However, we do need to associate it with a security group. So I'm going to select the same security group, the PAPS Dev App security group, which allows inbound traffic on port 80 only. Okay. And the reason for this is I want to demonstrate how we can connect to these servers without opening inbound ports 22 or 3389. SSH and RDP respectively. Okay, and then again, advanced details, you want to make sure you select the instance profile. So the instance profile in this case is the SSM EC2 instance profile. And then finally, we're just going to go all the way down and we're going to click Launch Instance. So at this point in time, I'm launching two EC2 instances, one Linux, one Windows. Linux one is getting launched in App Sub 01, which is in US East 1A, and Windows is getting launched in US East 1B. Okay, so I'm just going to pause the video over here whilst I wait for my service to come up, and then we're going to proceed with the next step. Okay, and here we are with our two EC2 instances that I've now successfully launched. Now, the next thing that I want to quickly do is take you into Systems Manager and show you how this all works. So let's go into Systems Manager next. We'll open that up in another tab. And this is your Systems Manager main console. window, and you've got a wide range of different tools that you can use on the left hand side that forms part of the Systems Manager suite. The one we're interested in is under Node Management. If we go to Session Manager, okay, this is where you can launch various sessions with your EC2 instances. So currently there are no sessions running. We can start a session, and that will bring up the 2 EC2 instances that are able to communicate with Session Manager. And the reason why Session Manager is able to see these 2 instances is because A, there's a System Manager agent that's pre-configured in the AMI, which was used to launch the instances, and B, we have used an IAM instance profile and IAM role to allow Systems Manager and EC2 instances to talk to each other. Okay, so what we can now do is go into the Linux, highlight the Linux one, and click Start a Session. And what you will notice is that we're connecting to the EC2 instance. We are basically able to log on to the EC2 instance and perform all kinds of administrative tasks without having to open those inbound ports or use an SSH client. So I can just elevate my privileges to the EC2-user that is the standard user for your Linux 2 AMIs. Okay, I can also do a sudo yum update -y, and we can check and update our kernel and so on, and go ahead and start installing my applications or setting up some services that I need to set up on my EC2 instance. In the same way, I can also connect to my Windows server. Okay, so I can start a session with my Windows instance, and this time I'll be connecting using PowerShell. Okay, and launching on the Windows PowerShell command, and I can just go, who am I? I'm logged in as the SSM user. Okay, so when you're connecting to these instances using Session Manager, you will be using the SSM user identity, and we can obviously navigate through the file system on Windows here as well. So I can do a cd/ and a dir, and I can list out all of my directories in the root of the C volume on this server. Fantastic. So at this point, we're obviously able to connect to our EC2 instances without having to use SSH clients or open inbound ports. I'm going to just terminate these sessions very quickly. And let's terminate that one as well. That will take us back to the Systems Manager console, and essentially we've got our sessions that are terminated. If we look at session history, you can see that I've connected to my instances multiple times. These were the last 2 terminations that I just now performed. And essentially you have got some history as to how we logged onto those instances and we terminated our sessions. But there are no log files or streaming log data information to tell us, the interactions that we had with those instances, and that's something Session Manager is capable of doing. If I take you to preferences for a second, there are various preferences here that allow you to define some logging information that you can set up for Session Manager. So one such logging is the S3 logging feature. What this does is it allows you to send log data to an S3 bucket of your choice and store logging information about those EC2 instances and the Session Manager sessions that you use in order to interact with those EC2 instances. So obviously, in order to set up S3 logging, we'll need an S3 bucket. Let's go ahead and set up an S3 bucket very quickly. And we'll just open up S3 in another browser tab. Okay, and what we need to do next is actually create a bucket. So we're going to create a brand new bucket. So I'll click Create Bucket, and I'll call this one S3 SSM logs. Okay, so that is just the bucket name, and it's going to be the US East 1 region, and we'll just go ahead and create that bucket. So we've just created a bucket which is going to be used to store our logging information. And now what we can do is we can go back to Session Manager and edit the preferences tab, edit the preferences page. And if I scroll down a little bit, go to S3 logging, enable the S3 logging feature, we can actually enforce encryption to allow only encrypted S3 buckets to send our log information to. And in fact, by default, when you create an S3 bucket, encryption is enabled, the S3 SSC encryption specifically. Let me just quickly show you where that is. So if you go into properties of your S3 bucket, and go down to default encryption, you will see that the Amazon S3 managed keys, SSE S3 encryption service is enabled by default. So back to my session manager, we're going to allow only encrypted buckets. So we're going to choose an S3 bucket that has encryption enabled. So I'm going to select the S3 bucket. So that's the PAPS S3 SSM logs bucket. You can also place your log files in a subfolder within your S3 bucket. I'm just going to leave that as it is for now and not bother with that for a second. And I'm just going to click save. So essentially what we have now done is we have configured S3 logging. We've defined the S3 bucket that we're going to send that log information to. Now there's still one more element that's missing in this puzzle in getting everything to work, and that's the fact that whilst we may have set up an S3 bucket, we also need to ensure that our EC2 instances ultimately has the permissions in order to talk to the S3 buckets as well. And so ultimately what we need is to create a custom policy for S3 access, okay, and update the IAM roles that those EC2 instances have already been configured with. So if you remember, if we go back to the instances themselves, take this one for instance, if we go under security, it is associated with this IAM role, the SSM EC2 instance profile IAM role that we created earlier. If we go to the IAM console, in the role, you will see that the only permissions that have currently been defined are that of the Amazon SSM Managed Instance Core permission, which is a permission to allow, that communication with EC2 instances. But if we're going to send log data to S3, then we need to add some permissions to allow that interactivity, that ability to talk to S3. And so what I want to do is I want to introduce you to another set of permissions. And I'm going to create a policy. So let's create a new policy. Create a policy here, and I'm going to go into the JSON tab, and the sample policy that I'm pasting in this window is available to you in our GitHub repository in the resources section of this video or down below in the description box. But essentially this is an important policy that's going to allow that communication to take place, that for those log data to be sent to Amazon S3. Okay, and ultimately what we need to define is the bucket that we are connecting to. So the bucket that we're connecting to is this one over here. So that's the PAPS-S3 SSM logs. Okay, so we're just going to update the bucket name in there, right, and that as well. And what we're doing here is we are giving us the ability to retrieve objects, put object ACL, get encryption configuration, and that's for the bucket and the contents of the bucket. Okay, so we'll click next for tags, and I'll skip that for a second. Click next for review, and we'll give this a policy name. So I'm calling it SSM logs policy. And then what I need to do is go back to my role, and that's the SSM EC2 instance profile role, and I'm going to update the role with this new policy. So this was the SSM logs policy. So we'll add those permissions as well. And now we're in a position where communication and log information can be sent to that S3 bucket. So we can quickly do a test. We can go into Systems Manager, go up to Sessions, click Start a Session, click on one of our servers, click Start a Session, and we should be able to connect to that server. And we can. So if I do a sudo su to give me root permissions, and maybe if I do something like who am I, then obviously I'm now logged in as root. If I do an exit and then an exit to terminate the session. If I now take you back to the session history, you will see that there's a new output location button over here. Okay, so that's actually taking me to the S3 bucket itself. So in fact, if I just take you to the S3 bucket, go into objects and do a refresh, you will see that we have log information being delivered to the S3 bucket. So I can go into the log file, I can actually open that up, and there we are. So what you can see here is that my script started at a particular time. I was able to connect to the server, and in fact you can see how granular this is, how detailed this is. It even lists out all of the command that I ran in my session manager. So the sudo su command, the whoami command, the exit commands are all listed out in that log data, which is really cool because it means that you can really audit all of your sessions right down to the minute interaction that you performed on your EC2 instances. Okay, let's take a look at another logging feature. So another logging feature that we have is CloudWatch logging. Now with CloudWatch logging, we can send the same stream of log data, the same stream of interactions that we're performing on our EC2 instances to CloudWatch logs group. And in fact, we can also enforce CloudWatch log encryption. Now, when it comes to CloudWatch log encryption, you do need to configure KMS. Okay, so KMS stands for Key Management Service. That allows you to create your own customer managed keys in order to manage your encryption and decryption of data. And so before we actually configure CloudWatch logging, what I need to do first is show you how to configure a KMS key that we will use for encrypting that log data. Okay, so as a precursor to configuring CloudWatch logging, we'll move on and set up KMS. If you remember actually from the original diagram, okay, we have KMS in place that is going to ensure that all of that logging information is encrypted, all of that data that's been transmitted is encrypted, and that's why we need to configure KMS first before we can go ahead and configure CloudWatch logs. So let's go into KMS next and configure a KMS key for the purposes of this lab. Okay, so back at our console, I'm just going to open up KMS in another browser tab. And we'll proceed to configure a KMS customer managed key next. And so to create a key on the AWS KMS console, you need to just click create a key. We're going to be creating a symmetric key. So it's a single key used for encrypting and decrypting data. And also it's going to perform both encryption and decryption services. We're going to also keep it on a single region. Okay, so the North Virginia region, and then I'll click next. And then you need to provide an alias name for your key. So we're going to call this one something like SSM logs key. You can give it a description if you like, click next. And now what you need to do is specify your key administrators. So these are the IAM users or roles that can administer the key through the KMS API. Now, we've got a few users that are already pre-configured in this account that have admin privileges. George, as per our diagram, is an administrator. He's got full admin rights. We're going to give him the ability to administer the key. And so I'll click next. And we'll give George the ability to use the key as well. So George will be able to use the KMS key in cryptographic operations, and we'll click next. And then finally, we'll click finish. Now that creates the key for you. It also provides you with a key policy. Okay, so if you look at the policy, that's the policy that grants the necessary permissions for George to perform all the wonderful tasks of encryption and decryption. Okay, what we need to bear in mind at this stage, and if you look at the key policy in detail, we're allowing the root user, okay, the owner, to perform all KMS operations. We're allowing George to perform a wide range of administrative tasks on KMS against the key. Also, we're allowing George to perform encryption, decryption, generation of data key, and describing the key as well. Okay, so those permissions are defined in the policy. What you would have noticed is that there isn't anywhere in there the fact that CloudWatch can make requests to use KMS for encrypting and decrypting. And so that's something that needs to be amended. So specifically, I'd like to show you a sample policy statement that can be used in order to allow CloudWatch logs to now interact with KMS. Okay, so we are now giving CloudWatch logs the permissions to perform these KMS operations. We need to make a few modifications to this policy though before we update our key policy, our KMS key policy. And for one thing, we need to put in the right region, because remember, this is a single region operation. Okay, and we need to do that there as well. So US East 1, and also I need to put in the account ID, and your account ID is available in the drop down over there. So let's just grab the account ID. And we'll just update it there. Okay, so that's our account ID. I'm literally going to copy all of this. And again, this policy sample is available to you in the resources section of this video in our GitHub repository. And we're going to edit our KMS key. And we're just going to place it somewhere here. This should do it. And if I paste it in there, and then we'll save changes. And now what we've done is we've updated our KMS key policy so that we can allow CloudWatch logs and CloudWatch logs group to interact with KMS. Okay, so this part of it is done. The next thing that we need to do is now also consider the fact that your EC2 instances have to have the permissions to write those streams, those logging information. Your session manager and your EC2 instances have to send that logging data to CloudWatch logs. So let me take you back to the IAM console. Now in the IAM console, for the role that we designed for our EC2 instances, we have specified two sets of policies. One is the Amazon SSM Manage Instance Core. That was standard. We then added another policy called the SSM Logs policy for S3 specifically. And if you remember, this was to allow, the logging information to be written to that specific bucket, okay, performing these operations to S3. What's missing from this policy and what's missing from this IAM role, however, is the fact that we also want to send the same log information to CloudWatch logs, which is what this whole process is all about, right? So we need to update this policy document further, okay, with an additional set of statements that will allow communication to take place to CloudWatch logs. Okay, so the previous update that we did in the KMS console, which was to do with the key policy to allow CloudWatch logs to interact with KMS, now that we have that in place, we also want to ensure that your EC2 instances are able to effectively create log streams, put log events, and describe log groups. Okay, so we're going to update this policy further. And so here is the sample policy that we're going to actually be using to update our existing policy with. And what we're doing is we're basically now allowing communication and transactions to take place with CloudWatch. So we want to perform CloudWatch logs actions. Okay. Also, what we want to do is we want to be able to decrypt our KMS key. Okay. And the only update that you need to do in this policy before using it is to update the KMS key ARN. Okay, so we can go into our KMS, the key that we created earlier, copy the ARN, and then just plug that value in the placeholder here. So I'll just place that, and then we're just going to copy this entire policy statement block, and I'm going to edit the existing policy, SSM logs policy, go into the JSONs tab. And after this curly bracket, you need to just put a comma because you're adding another statement block, place that value in there, and pretty much you shouldn't get any errors, and then click review policy and click save. And at this point in time, we've updated our policy with the ability to write to S3, okay, with the ability to write to CloudWatch logs and also to decrypt using our KMS key. Okay, so we're good with the policies now. We're good with the IAM policy as well as the KMS key policy. The next thing we can do is test this out. We're going to enable encryption in our transactions with the EC2 instances, but also we're going to set up a CloudWatch logs group and configure that logs group to only accept encrypted traffic, okay, and for the data to be encrypted in that logs group. So the next step is we're going to go ahead and jump on into CloudWatch. Okay, so the next thing that we're going to do is go into Amazon CloudWatch. We'll open that up in another browser tab. And in CloudWatch, what we need to do is set up a logs group, which will be used to store all of the streaming data for auditing purposes. So on the left-hand menu, go down to logs group, and we'll create a new log group. Let's call this one SSM CW logs. Okay, so something we can easily recognize. And we'll set the retention period to 3 days. Okay, now because we want to encrypt our data, we need to provide the KMS key ARN. So I'll just grab that from my KMS console, copy the ARN, and place it in there. So that's our key ARN, and then we'll click create. At this point, we've effectively created the CloudWatch logs group that we'll be using to send all of that encrypted streaming log data to. So now that this is set up, we're going to go back into Systems Manager, make a few configuration changes, and perform some tests. Okay, so here we are at Systems Manager. Now in Systems Manager, we'll make a few changes under Preferences first. I want to take you through a couple of steps specifically, just to showcase how this all works. So if I click on Preferences, One of the features that we can enable under general preferences is to enable KMS encryption. So let's do that first. So I'm going to edit that and I'm going to enable KMS encryption. And when you do that, you need to select the KMS key that you're going to use. So we've created this key over here, the SSM logs key, when we were working in KMS earlier. Let's just go ahead and save that first. Okay, so that's saved. And then what I want to do is actually connect to one of our instances. So I'll start another session. Let's connect to the Linux instance and click start a session. And what I want to show you here is exactly a message that will pop up. So you see it says this session is encrypted using AWS KMS. So you know that you're now connected using an encrypted session. And obviously we can then perform all our tasks that we need to. So let's just get out of this session again. And I'm just going to exit that. Okay, the next preference that I want to show you is the CloudWatch logging. So if we edit this and we scroll down to enabling CloudWatch logging, okay, we're going to be basically logging all of the stream sessions logs. So this will have all of the session data streaming continuously to CloudWatch logs during the session. And this is particularly useful if you want to have that granular information about all of the interactions that takes place on your EC2 instances for auditing purposes. Once you select that option, you obviously then need to select the actual logs group that you're writing to. So that's the SSM CW logs. So we'll select that one over there. And finally, you want to enforce encryption. So you want to ensure that this box is ticked, which says allow CloudWatch logs groups that are encrypted using the CMK, the customer master key of your KMS. Okay. And the policies that we set up earlier is going to enable this all to happen. So finally, we'll go down and click save. So that's in place as well. Okay, so the next thing that we need to do is do some tests. So I'm going to click on sessions, click start a session. And we'll connect to our Linux instance and I'll click start a session there. And what you should see is a message that pops up that says this session is encrypted using AWS KMS, just like the last time, which is perfect. But let's go ahead and elevate our privileges. Okay. And maybe we can say, who am I? And I'll say I'm root because I've just elevated my privileges. And let's do a yum update -y. And it does any updates that it needs to do. Otherwise, if there are no packages marked for update, then that's also fantastic. And then finally, I can say exit and then exit again. So now I've terminated my session. Let's go back to session history. And what you should notice is that, in fact, I've got two output locations. I've got my S3 and CloudWatch logs as well. Okay, so now CloudWatch logs is also getting that streaming data. So let me take you to CloudWatch logs, the CloudWatch Management Console. We can go into the logs group. You can see the log stream. So there's the latest one. And you can see the information that is being logged. So I connected to the session. I ran a sudo su, another task, a yum update -y. And it found some packages. And you can see all of this information is available to you in terms of the action that you're performing. So for instance, remember where it said no packages marked for update, all of that data is getting recorded. And then I exited the session and finally exited and terminated the session as well. So all of this data is being stored for you, okay? And you are able to then audit all of your interactions with your EC2 instances in this stream in CloudWatch logs. Okay, so now that we've showcased how to configure SSM Systems Manager, okay, and you can obviously see all of the different parameters have been enabled, the encryption, the writing to CloudWatch logs, the writing to S3 logging. The next thing that I want to quickly take you through is how you can perform remote administration of your Windows instances using the GUI interface. So let's do that next. And so I wanted to quickly show you this diagram again, just to go over what we're going to be doing next. George, our systems administrator, is using a local client computer in order to remotely administer our Linux and Windows servers in the VPC. For the purposes of this exercise, I just want to quickly demonstrate how George can use an RDP client to connect to our Windows servers so that he can get access to the GUI interface. Now, on your local machine, you will need to install a couple of tools in order for this all to work. The first one is you'll need to install the AWS CLI on your client machine. That can be for your Windows machine or your Linux machines or your Mac machines. You also need to install the AWS Session Manager CLI plugin onto your client machine as well. Now, I appreciate the fact that this video is quite an extended one, so I didn't want to go through the process of installing these tools as well for you. However, I will provide you with the links required in the resources section of this video or in the description box below of where you can get these tools from and install them. Specifically, you've got a step-by-step guide on how to install the latest version of the CLI. So if you are using a Linux, Mac OS or Windows machines, the instructions are provided there for you. Okay, you want to make sure that you install the latest version of the CLI though. And then once you've done that, you can install the Session Manager plugin for the CLI. Again, that can be either for your Windows, Linux or Mac environment. So if you've got a Windows machine that you're using as your client computer, the instructions are there. If you've got a Mac machine, then obviously the instructions are there. I've gone ahead and installed these tools on my Mac computer already. So I'm going to proceed with the next step of showing you how to configure the Mac environment, the CLI specifically, in order to then proceed to connect to my Windows server running in the private subnet of this VPC. So we'll do that next. Now, once you've installed your CLI, you need to configure it with a particular IAM user that you're going to use in order to interact with the AWS platform with. So I'm going to take you back to my IAM console and specifically go to users. I've already created a user called George, but George will require an access key combination in order to perform the necessary administrative tasks. So George is a member of the senior admins group, and the senior admins group has assigned to it, and we'll take a look at that for a second, the administrator access permissions. Okay, so George has been given lots of permissions, and I've done this only for the purposes of making this lab easy to run through. You may wish to have more granular permissions, however. Now, if you go to security credentials, what we need George to have is some access keys. So we'll create an access key for the command line interface. We'll click next on that one. And you need to say this by understand and then give it a value. So let's call this George's keys. Okay, George's secret keys, something like that. And then we'll click create access keys. So those are the keys created for you. Okay, and that's all fantastic. What we need to do next is we need to configure the CLI that you have installed on your machine with these keys. So I'm going to go and open up terminal window on my machine. Okay, and this is my terminal window, and you will need to type in AWS configure. Okay, and then provide the keys. Now, you could set a profile for George if you're having multiple users access the same client. I'm just doing it as the default profile. If you were using the profile, previously we've discussed this in the IAM section of our course, you would need to just do -- profile at the end of this command, configure command, and then provide the profile name. But I'm keeping things a little simple over here. So the access keys that we want is that one. Okay, so we just paste in those access keys. And then I'm just going to put in the secret access keys as well. So let's copy that in. And I'm going to leave it as US East 1, and the default output format, we're just going to keep it as its default value. So now the access keys are in place. We're going to be able to then move on to the next step of connecting to our server. Now, we have already installed the Session Manager CLI plugin as well. Okay, so you do need to make sure that you do that before you can perform the next step. So once you have your Session Manager plugin installed and the CLI configured, you actually need to log on to your EC2 instances running your Windows server, and you need to configure it with a Windows OS user. So let's do that next. So we're going to click on Start a Session. We're going to connect to our Windows EC2 instance. And that will set up and connect us to the PowerShell. And what we need to do first is we need to set up a username and password for our Windows environment. Okay, so we'll be using that username and password to connect to it using the RDP client. We're going to provide a command here that basically allows us to define a password as a secure string. So it's going to prompt you for a password. Okay, so now we need to provide a password. So this is the password that I'm typing in that's going to be used for the user. And then we're going to create a local user to use this password. Okay, so let's just provide another command. And now this next command allows us to basically define a new local user on this Windows machine. Okay, so new local user, we're going to call it user1, user 01, and that user is going to use the password that we just defined the variable for in the previous command. So we'll provide that in there. Okay, so the user has now been created. We're also going to add this user to a local group that is available on all Windows machines called the remote desktop users group. Okay, users that are part of this group have been granted the ability to make remote desktop connections. This is a default configuration that's available on Windows machines. So that's why we want to ensure that user 01 in this case is able to make that connection, that remote desktop connection. Okay, so that basically puts the user in the group, the remote desktop users group. And once that is in place, we can go ahead and terminate this session, exit out of it. Now, the next thing that we need to do is actually go back into our terminal window on the local machine. So on a Mac, you use the terminal. On a Windows, you'd use the command line interface or the command tools. And you will be using the AWS command line interface in order to basically set up a session to your server. So what we're going to be doing first as a precursor to actually launching our RDP client is running a command that will start a session with our Windows server. And the command is basically AWS SSM start session. Now we need to provide the instance ID of the actual server that you need to connect to. Okay, so essentially we would update this command. And where you have the placeholder called instance ID, you just want to put in the instance ID of the Windows machine. So I'll quickly grab that from my instance console. So that's the Windows server that we're going to be connecting to. So this is that one over there. And we'll just paste in that value. So that's the instance ID of the server that I want to connect to. Okay, and what I'm doing is I'm using a local port number and a remote port as well for the 3389 connection. So you enter that and that provides a session to your server. Now, whilst that session is in the running state, whilst it's waiting for a connection, we can proceed to open the remote desktop client. Okay, so I've got the Microsoft Remote Desktop tool that I've installed on my local computer. I'm going to click Add a PC. The PC name is going to be the actual local host and the port number that I've specified in here. So this port number 55678, that's going to be what I'm connecting to because I've already established this session using my terminal. Okay, now what I'm doing is I'm trying to force the RDP connection through that session that I've established via Session Manager. Okay, so we're just going to put that value in there. And then obviously we can add the account details next. So we're going to put user 01 is the account that we're going to be connecting to. Okay, so user 01 was the user that we created earlier when we had remotely connected to that session on the Windows server. And then finally we will click add. So that adds the server and then we can just make a connection to it. You'll get this error message or this warning message that says you're connecting to an RDP host. The certificate could not be validated. Are you sure you want to continue? Just say yes, you want to continue. And then we need to put in the password. So this is the password that you essentially configured a few moments ago when we had established the session to the actual server. And what you should get is a user interface to the Windows Server desktop. Okay, so your RDP connection to the Windows Server desktop, and it will allow you to connect over that RDP connection. So what's actually happening here is the RDP connection is being forced through Session Manager rather than you having to open port 3389 for the RDP connection inbound on a security group that's connected to the server. And furthermore, rather than having a bastion host set up and configured in your VPC in the public subnet, which would add to the management overhead of maintaining and managing that bastion host and also incur higher security risks. So here we are, we're connected to our Windows server in the private subnet of our VPC, fully interactive by forcing or enabling RDP session through Session Manager. Well, I hope you enjoyed this video and were able to benefit from the full step-by-step guides. Now remember, in the GitHub repository, the link of which is available to you in the resources section of this video and in the description box below, you have got all of the sample policies as well as the necessary commands in order to do this in your own AWS account and lab environment. And so the last thing that you need to do, obviously, is once you're done with your session, you can exit the session from Session Manager and disconnect your session from the EC2 instance that you were running that remote desktop connection through. Now, I just wanted to quickly run through some cleanup processes, because remember, you're running multiple resources in this particular account and you're going to be charged if you just continuously let it run. So the first thing we can do is obviously we can go ahead and terminate our EC2 instances because we don't need them anymore. Okay, so that is going to terminate your EC2 instances, as that's going to shut down your EC2 instances. Okay, also probably what you want to do is you want to go into your CloudWatch logs group and get rid of that CloudWatch logs group if you don't need it anymore, so we can get rid of that. Okay, so that's gone. On top of that, you may also wish to get rid of this customer managed key, because remember, you are incurred some cost for that as well. So we can disable the key and you can confirm that you want to disable the key. Okay, so we'll disable the key and the key is then disabled. And then you can obviously schedule the key deletion as well. And you can actually specify a waiting period between 7 to 30 days, so we'll put 7 days over there, and confirm that you want the key to be deleted. So we'll schedule key deletion as well. So we've terminated our EC2 instances, we've got rid of that CloudWatch logs group, we've disabled the key, we've set it for deletion. Okay, you can obviously also get rid of the S3 bucket. Okay, so perhaps S3 bucket, you will need to empty the bucket first. Okay, so that's critical. Before you can actually delete a bucket, you do need to empty the bucket. So you just go in there and do a permanent delete as the input field. So it's permanently delete. Okay, and then just empty. That empties the bucket. Okay, and then what you can do is you can go ahead and actually delete the bucket as well. And you just need to put in the name of the bucket to confirm the bucket that you're deleting, and delete the bucket. So that's the bucket deleted. Finally, what you do need to do is, if you go into your VPC, I'm going to let obviously the VPC continue to exist because we use it in our various labs, but what you want to get rid of is the NAT gateway. The NAT gateway is a chargeable service, doesn't fall within free tier. So let's go ahead and get rid of the NAT gateway as well. One of the things that does happen when you delete the NAT gateway is that when you go into your route tables, okay, remember we have our main route table which has a route to the internet via the NAT gateway. Well, that gets referenced now with a black hole because there no longer is the NAT gateway. So we can just quickly edit that as well, and we can just remove that entry and click save just to clean up things a bit further. Okay, and then lastly, if you want, you can go ahead into the IAM role and get rid of the IAM role. So the role that we created was the SSM EC2 instance profile role. I'm going to let that continue to stay, however, for some future labs and exercises. Okay, and so that brings us to the end of this video. I'll see you guys in the next. Thank you.